To get started, go ahead and evaluate this quotient, 1 divided by 3/5. You can also think of 1 as 1 over 1, so this is 1 over 1 divided by 3 over 5. And if you're not sure how to divide these fractions, click down here to review. Right, to divide fractions, you can take the first fraction, 1 over 1, and then flip the second fraction and multiply. So this quotient equals 1 over 1 times 5 over 3, which is just 5/3. Now for any number, like the number 3/5 over here, the reciprocal is 1 divided by that number. So the reciprocal of 3/5 is 5/3. In general, you can always find the reciprocal of a fraction by flipping it over. So next, try finding the reciprocals of these fractions. You can divide 1 by each of these numbers, or you can use this trick. Exactly, the reciprocal of 7/4 is 4/7. The reciprocal of 2/11 is 11/2, which also equals 5.5. And the reciprocal of 1/8 is 8 over 1, which is just 8. Now what about decimals? For example, what's the reciprocal of 0.25? Well, that's 1 divided by 0.25. If you type this into a calculator, you'll see this equals 4. You could also write 0.25 as a fraction. 0.25 is the same thing as 1/4. So then the reciprocal of 1/4 is 4 over 1, which equals 4. So whether you divide 1 by the decimal or you write the decimal as a fraction and flip it, you'll get the same answer either way. Next, find the reciprocals of these three numbers. Feel free to use the calculator down here. Nicely done. 1 divided by 2.5 is 0.4. The reciprocal of 9 is the fraction 1/9, which you can also write as 0.111 and so on. And 1 divided by 0.37 is approximately 2.7027. Now another name for reciprocal is multiplicative inverse. They mean exactly the same thing. The multiplicative inverse of a number is 1 divided by that number. Now suppose you have a number and you multiply it by its multiplicative inverse, also known as its reciprocal. What product will you always get? Excellent! For any number you take, like 2/9, when you multiply by the reciprocal, also known as the multiplicative inverse, you always get 1. So what about negative numbers? Well, what's the reciprocal of negative 3/4? What number can we multiply negative 3/4 by to get 1? The answer is negative 4/3. If you multiply these two numbers, the minus signs cancel out, leaving you with 3/4 times 4/3, which equals 1. So the reciprocal of negative 3/4 is negative 4/3. For negative numbers, you can still flip the fraction, but hold on to the minus sign. Next, try finding the reciprocals of negative 10/7 and negative 1.6. For this one, you might want to use the calculator again. Great, so the reciprocal of negative 10/7 is negative 7/10, and 1 divided by negative 1.6 is negative 0.625. Next, can you find a number that equals its multiplicative inverse? So what fraction, if you flip the numerator and denominator, gives you the same fraction back? Nicely done. That was a tricky question. It turns out there are in fact two numbers that equal their reciprocals. One such number is 1, which you can write as 1 over 1. If you flip this fraction, you still get 1 over 1. The other number is negative 1, which you can write as negative 1 over 1. If you flip this fraction, you still get negative 1 over 1. So both 1 and negative 1 are their own multiplicative inverses. Finally, it turns out there's exactly one number that does not have a multiplicative inverse. In other words, when you try to divide 1 by this number, you just can't do it. Any idea what this number might be? Precisely. If you ask yourself, what's the reciprocal of 0, then you'd say it's 1 divided by 0. But whenever you try to divide by 0, the result is undefined. there's no number that equals 1 divided by 0. So 0 does not have a multiplicative inverse. So to summarize, the multiplicative inverse of a number is 1 divided by that number. And to find the multiplicative inverse of a fraction, you can flip it over. And another word for multiplicative inverse is reciprocal. To get started, which of these green regions represents the fraction 2/3? Right, this is 2/3. Now what about a fraction like 5/3, where the numerator is greater than the denominator? Which of these illustrations has 5/3 shaded green? Nicely done. So this represents 5/3. If you were describing this fraction to someone else, you might say that you have one whole dot and then 2/3 of a dot. And that's actually another way to write this fraction. And you can read this aloud as 1 2/3. 1 2/3 is the same thing as 5/3. When you write it like this, as a whole number and a fraction, it's called a mixed number or a mixed fraction. Writing it like this, where the numerator is greater than the denominator, is called an improper fraction. So next, what mixed number is equal to the improper fraction 9/4? Exactly, 9/4 equals 2 1/4. To see that, you can draw out all 9/4. Here are 4/4, and here are another 4, giving us a total of 8. So let's add one more over here, giving us a total of 9/4. And as you can see, this is equal to 2 1/4. Now suppose you start with a mixed number, like 6 3/7. How can you write this number as an improper fraction? If you're not sure, just click over here. Nicely done. So 6 3/7 equals 45/7. 6 3/7 is the same thing as 6 plus 3/7, and we can rewrite 6 as 42/7. 42/7 plus another 3/7 equals 45/7, which is the correct answer you found. Try one last example. Which improper fraction equals 3 4/5? Enter the numerator and denominator over here. Here we'll explore how the distributive law can be used for division. But first, let's look at multiplication. Which of these expressions is equivalent to 4 times 8 minus 3 in parentheses? Right, this equals 4 times 8 minus 4 times 3. 8 minus 3 equals 5, and 4 times 5 is 20. Down here, 4 times 8 is 32, and subtracting 4 times 3, or 12, also gives you 20. So you can always distribute multiplication onto numbers being added or subtracted inside parentheses. So what about division? Suppose we have 15 plus 6 in parentheses, and then we're dividing by 3. Can we distribute this division? Is this the same as 15 divided by 3 plus 6 divided by 3? Evaluate these two expressions to see if they're the same. Nicely done. 15 plus 6 is 21, and dividing by 3 gives you 7. And down here, 15 divided by 3 is 5, and 6 divided by 3 is 2. Adding 5 and 2 gives you the same result, 7. So yes, the distributive law also works for division. And we can also write these divisions as fractions. So 15 plus 6 all over 3 equals 15 over 3 plus 6 over 3. So the distributive law for division is actually the same thing as the rule for adding fractions with the same denominator. Keep the denominator and add the numerators. So, by the distributive law for division, 94 minus 23 all over 7 is equal to which of these expressions? Great, so these two expressions are equal. And so whenever you're adding or subtracting two numbers and then dividing by another number, you can distribute the division. But what if you're dividing a number, like 24, by a sum, like 6 plus 2? Are we still allowed to distribute the division? So does 24 divided by the sum 6 plus 2 equal 24 divided by 6 plus 24 divided by 2? Evaluate these two expressions to find out. Right, so 6 plus 2 is 8, and 24 divided by 8 equals 3. Down here, 24 divided by 6 is 4, and 24 divided by 2 is 12. 4 plus 12 equals 16, so these two expressions are not the same. We can write this using an equal sign with a slash going through it, meaning these two expressions are not equal. And we can also write this as fractions. 24 over 6 plus 2 does not equal 24 over 6 plus 24 over 2. So here's how to distribute division. If you're adding or subtracting numbers and then dividing, you can distribute, dividing each of the terms and then adding or subtracting. But if you're dividing a number by a sum or difference, you are not allowed to distribute. If you try, you'll get the wrong answer. Suppose I tell you that each ticket to a show costs $100. How much would 7 of these tickets cost? Right, that wasn't too bad. If each ticket is $100 and you have 7 of them, then the total price is 7 times 100, or $700. As you'll see, when the word of is used in word problems like this, saying you have some number of something, that means you can find the total amount by multiplying. Let's see another example. Suppose you have a lot of bricks, and each one weighs 4 pounds. So then how much would 60 of them weigh together? Right, each brick is 4 pounds and you have 60 of them. So the total weight is 60 times 4, or 240 pounds. Next, suppose a tank holds 50 liters of water. Now how much water does half of the tank hold? Right, now you can solve this by saying that half of 50 is 25. Another way to get the same answer is to say you have 50 liters and you want half of it. So that means you're multiplying by 1/2. Sure enough, 1/2 times 50 equals 25. Let's try another example. Now every marathon is approximately 26.2 miles long. So then how long is 3/4 of a marathon? Again, notice the word of here. And be sure to give your answer to 2 decimal places. Great, so a marathon is 26.2 miles and we want 3/4 of it. So that's 3/4 times 26.2 miles, or 19.65 miles. Even 3/4 of a marathon is a pretty long distance. Okay, so now let's look at some questions without units. For example, what's 5/8 of 120? Nicely done. You could take 120, divide it up into 8 equal parts, and then count out 5 of them, and you'd get 75. Another way to solve this is knowing that the of signals multiplication. So 5/8 of 120 is 5/8 times 120, which again equals 75. Next, try an example with 2 fractions. What's 2/9 of 4/7? Precisely, this equals 2/9 times 4/7. You can multiply the numerators and denominators to find that this equals 8/63. Finally, here's an example with an improper fraction, where the numerator is greater than the denominator. But you can calculate this answer the same way you've done it for all the previous questions. So what is 9/4 of 200? Right again. If you have 200, then 9/4 of it is 9/4 times 200, which equals 450. So whenever you have some number of something, you can multiply to calculate the resulting amount. Again, nicely done.